One of the things we do in this course is we use Euler's identity a lot. So we interchange between exponentials and simple cosines. So how are they related? Let's just do this from scratch. Let's draw a circle. Now, it's not a perfect circle. It'll have to do. So there's the x-axis. There's the y-axis. This is a unit circle, so the radius is 1. And here's theta. So we can write this point in complex number form. Very straightforwardly, x plus jy is equal to z. That's a point on the circle. Well, in terms of trig, we can say z equals cosine theta plus j sine theta. And of course, what's the value of z when theta equals 0? Well, we're along the x-axis, so we also know that, put it down here, z of 0 is equal to 1. Another thing about this representation that's not mentioned too often when you start is theta is which angle? Like here it looks like 45 degrees, but it could have another 360 and another 360, and you don't know where you are. So we don't want to think we're always going around a screw in units of 2 pi or 360. So we'll always restrict ourselves to go from 0 to 360, from 0 to 2 pi. Then everything is well defined. All right, I want to differentiate this with respect to theta. We could do that because we've defined the angle properly. Minus sine theta plus j cos theta. Not a big deal. Notice that minus 1 can be written as j squared, so we can factor out a j. You say, that's not a big deal either, but look, this term, what is that? That's z. So we get an equation, dz by d theta equals j z. So this is not tremendously peculiar. Notice the interpretation, it would be the tangent vector here by the definition of derivative. So if this was position, this would be like velocity. And notice the direction is right because when you multiply z by j, it just rotates it by 90. So there it is. But we want to play with that equation a little bit, so we're going to integrate it. dz over z equals j d theta. We integrate it. Log z is equal to j theta plus a constant. Now, quick word about the integration. Wait a minute, this is a weird complex number. How are you going to integrate it and get log z? Well, it turns out mathematically, since we defined the angle from 0 to 2 pi, the integration is well defined. We're not going up a screw on units of 2 pi, so we can integrate that. Now let's exponentiate this integral. E to the power log z, which is equal to z, is equal to e to the j theta plus c, which is equal to e to the c times e to the j theta, where c is a constant. What's the constant? Well, we know that z of 0 equals 1, so that's equal to e to the c, and e to the 0 is 1, so e to the c is 1. So this term is 1. So we get the final result. Z equals e to the j theta, which is what? That. We've just shown one of the most famous results in mathematics, and it's absolutely rigorous. E to the j theta is cos theta plus j sine theta. We use that all the time in our discussion of waves.